Hello everyone, welcome back to my channel. I'm Niranjan Chandrapal, mathematics teacher at Cambridge International School, Doha, Qatar. Today we are going to learn about how to use the reduction formula in solving questions for further pure mathematics. So this is the subject for A-level students. Normally the students who are high achiever as well as they want to be doctor, engineer, scientist, they normally take this subject. So only few schools in Qatar offer this subject. So as a subject expert, I'm going to explain the students to how to use the reduction formula and how to use the integration by part in solving basic questions as well as some past paper questions. Let's have a look. Students, we are going to use the reduction formula in integration. So basically this formula usually include like power of sine, power of cosine, and then power of tangent. These three are the basic. And also we have the exponential integral type of form. So that is x to the power n and e to the power x. So for trigonometry also they use like that, x to the power n sin x, x to the power n cos x. So key formulas like used in this chapter, normally this is the first formula for sine. So let's see how the formula is. So you can understand this one easily. This is the formula. We can also prove this formula using the like integration by part. So sine to the power n x dx equal to minus 1 by n sine power n minus 1 x cos x plus n minus 1 over n integral n minus 2. So this will continue like that. So this is also like that for cos, and this is for the index. So mostly in this chapter you need to know the sine power and cosine power formula. Also you need to know the other one, I mean the index form. So let's see how to use this formula at basic questions. For example, sine square x dx. So in this equation, you can see if I use this formula like sine formula. So this is the reduction formula. If you see this is the reduction formula. So in this reduction formula, I will use this. So look, the power is 2. So that means n is 2 here. So what I can do, I will replace in this equation n by 2. So the answer is what? Minus 1 over n. So minus 1 over 2 because n is 2 now. And sine power n minus 2, that is 2 minus 1. I'm just replacing n by 2 because there is sine square. Here is sine to the power n. So obviously I have to replace this n by 2 in this formula. So finally I got this one. That is I n minus 2, that is 2 minus 2 is 0. So I have to find out now I0. Part 1 is done. So I have to find now I0. So let's see how I can find out I0. So if I replace here 0, that is n will be 0. So then sine to the power 0 x dx. So as you know, anything power 0 means 1. So this is the index formula. Anything power 0 means 1. So there is 1 dx. And as you know, only 1 dx integration is x. So I will replace this one here now. So look, I just replace this one by x. And obviously as it's like indefinite integral, I have to use a constant c. Now one more thing you have to understand. This formula, I mean sin x cos x. As you know, if I have use the double angle formula, for example, if I say you know the formula sine 2a equal to sine 2 sine a cos 2 sine a cos a. So if I want to find out sine A cos A, that means 2 will come here. So it is 1 by 2 sine 2A equal to sine A cos A. It means whenever I will have, this one, I mean sine and cos. So this one sine x and cos x. So this one can be written half of sine 2A. That means half of sine 2x. In this equation, instead of A, there is x. So I will write half of sine 2x. And half, it becomes 1 over 4. So this is the final answer, like integration of sine square x by using the reduction formula. Same things I can use for cos. For example, now it is cos cube x. So as you know, the formula is this. So if I use in this formula, now x is n is 3. So I will replace here 3. This will be 3. This will be 3. Like wherever you will see n, it will be 3. So if I replace, then it will be 1 by 3 cos 3 minus 1, and then 3 minus 1 over 3 I 3 minus 2. Now this part becomes I1. And here it is 1/3 cos square x sin x. So now again I have to find out I1. So replace here by 1, then I will get I1. So if I get I1, so I1 will be, this one will be, n will be 1. So that is cos x dx. As you know, cos x dx integration is sin x. So replace it here. So just replace it here. Next, see this one. So you just replace it here. You will get sin x into c. So this is the final answer. So you understood how to use the reduction formula in cos cube x and also sin square x. Similarly, any power of cos and sin you can solve. Now let's look at this question. This is the past paper questions. Look, this is maybe 2025 Mason question. So how to solve this one? For this part, actually, I will not use the reduction formula. Rather, I will use integration by part. So if I go for that, so you know the integration by part, this is the formula u dv equal to uv minus v into du. Already you learned this formula, and this formula will also be given in the formula sheet. Anyway, but you have to remember that, other than you cannot use it. Okay, so how can I use this one? As you know, u and dv, so you need to take the index form as a u, then it will be easier to solve. So u 1 minus x whole to the power n, that means this part is u, this is u, and the other part is dv. So this is dv. So if I say this is u, and integration, the differentiation of that is easier if I take the index form as a u. So du by dx is n is coming out, and then 1 minus x, and again x integration is, there is chain rule here, it is minus 1. So that's why it is minus n 1 minus x whole to the power n minus 1. And as dx is over there, so it's, if I take in the other side, it will multiply. Similarly, dv is the other part. And remember this one, this is not sine, this is called sine, or it's called hyperbolic sine. You can say h means hyperbolic sine. You know, it has a meaning. You can see this one. So hyperbolic sine x dx, if I do the integration both part, so that will be v, and this part will, the sine will be cos. So hyperbolic cos x. So I know now everything I can replace in this equation. So just replace u and v minus, then again this integration according to the formula v is this, you can put the v here, this is v, and this is du. So this is u and this is v. So just replace in this formula, so you will get this answer. Now this part is easy because already this part is done. Just use the upper limit minus the lower limit. But this part again I have to solve because I have I n minus 2. So that is coming n minus 1. So I have to do this part again. So what I can do, uh, first of all I have to find out the like this part. How can I find out this part? I will put the limit. So when x is equal to 1, if I put it here, so it will be 1 minus 1 whole to the power n. So 1 minus 1 means 0. 0 to the power n means 0 to the power n means 0. So that means this total part will be 0. Again, here will be, this is 1 minus 0 is 1. So 1 to the power n is 1. 1 to the power anything will be 1. And then hyperbolic cos 0 it is almost 1. So that is 1 multiply 1 is 1. So upper limit 0 and lower limit is minus. As you know, integration you have to minus the lower limit from the upper limit. So 1 minus 1 is minus 1. That means this part will be negative 1. So this is negative 1. So what is left over here? I can rearrange this one. This one is a constant, right? So if I take this constant on the left side with this minus 1, it will multiply and it will be plus n. So and remaining is 1 minus n whole to the power n minus 1 and hyperbolic cos x. Now this part I will let something and I will do it again, because I have to go I n minus 2. That means this part again I have to do using the like integration by part. That means this formula. Let's see the next part. So look, now this part is organized in this way. So this part I will take as a j. So again the limit is from 0 to 1. So as you know, this one again I will use this formula. So I will say this is u and then this is dv. If I say this is u, so du by dx will be this. So this one, as you know, the power is coming, you know the differentiation. So if I do this one, n minus 1 will come out and then power will be reduced by 1. So n minus 1 minus 1, it will give you n minus 2. Again, this is not x. If I use the chain rule, so I have to do this one again. So 1 minus x differentiation is minus 1. That's why they just put it minus 1 here. I mean the minus sign. Again, dv is this one, hyperbolic cos x dx. So dv is hyperbolic cos x dx. So if I do integration in both sides, so that will be v, and hyperbolic cos will be hyperbolic sin x. Now replace this one in here. So if I replace this one here, then it will come like that. So this part is coming uv. So u is this one, as you know, and v is this one. Already we have written, I have written here, u is this, v is this. So uv and 0 to 1. And again, this part, I mean 0 to 1. So that is v du. So v is given this one, hyperbolic sine. So this is hyperbolic sine. This is v, and du is this one, because next part is d1. So d1 is written here exactly. Now I will simplify. So if I simplify this part, so this is coming like that. So first of all, I have to find out the limits. If I put the upper limit and lower limit, so upper limit is coming 0 and lower limit is coming 1. Again, no, sorry, lower limit also 0. So 0 minus 0 is cancelled. So 0. So that means this part became 0 now. So I have to go for this part only. So if I write this part again now, I can take this one out. Again, same way. This is a constant and there is a negative sign. So this negative with this negative will be positive. So that is n minus 1. And remaining is n minus 1 minus x whole to the power n. 1 minus, there is 1 minus x whole to the power n. So 1 minus x whole to the power n minus 2. So if I use this one, and there is also hyperbolic sine x. So this meaning, until this meaning is I n minus 2. This is I n minus 2. So I can replace here. So that is j equal to this. So I can now replace in the main equation. If I replace it here, everything, if I replace it here, so if I replace it here, then you can see the final answer is coming -1 and n j. So j is already, you know, n minus 1 into n minus 1 into n I n minus 2. So the finally the answer is this. So that is proved. Now the second part they says show that find the values of exact values of I2. Now I have to find out the I2. So as you know the formula In equal to this. So I have to replace this one by 2. Just replace it by 2. So if I replace n by 2, replace n by 2, n by 2. So what is coming there? So there is I2 equal to -1, 2 into 2 minus 1 into I2 minus 2. That means that will be -1 and that will be 2. 2 minus 1 is 1. So 2I0. That means I have to find out I0 again. So I have to replace here 0 now. Let's do in the next. So now you have to replace this one by 0. So if I replace it by 0, then it will be I0 is this. As you know, anything power 0 means 1. So that means hyperbolic sine x dx. So hyperbolic sine x dx integration is hyperbolic cos x. So hyperbolic cos x. So if I write hyperbolic cos x, so this is hyperbolic cos x. So then you have to put the upper limit minus the lower limit. And also I have to find out this one. You can use the calculator to find the exact answer. As this is said, prove that, they said show that this one equal to that. B said they will show that. So I will not write this one in number. I will just leave it like that. If I leave it like that and if I substitute in L2, they said L2 to find out L2, find the values of L2. So if I write L2 is this. So -1, and if I replace this one, that is 2I0. It was the answer before. So then I will put answer of I0. I0 is hyperbolic cos 1 minus cos of 0. So cos of 0 is a constant, so I can put it 1. So hyperbolic cos 1 minus 1. So if I multiply by 2, that will be 2 minus 2. So minus 2 will be -3 and 2 hyperbolic cos 1. So I2 equal to 2 hyperbolic cos 1 minus 2. So this is the final answer for that. Hope you understood a little bit. So more or less you have to practice. If you practice, then you will get a good result. And I do believe parents, teachers, students should connect together and help each other to success. Only like working together we can make our students successful. Thank you so much.